So multiplication rule, the fundamental principle behind multiplication rule is that you can simply multiply the number of ways a particular event could happen if they are independent. And if that is the case, the probability will also be the product of each of the probability of events. So let's say there are k experiments. You could call it experiment, you could call it a process, you could call it a study, call it whatever you want to call it as. Suppose there are k experiments and each of them so each of the k experiments can be conducted in n sub k ways. So if that is the case, so the number of ways all k experiments can be conducted simultaneously. Well, if all of them can be done at the same time, it sort of implies that, one experiment has no way to affect the other. So they are independent. So if that is the case, then what is the total number of ways in all k of them could happen? Huh?
K times nk.
K times nk, okay. Now here, I do have to say, maybe this is what led to confusion. So 1, 2, all the way up to n. So there is experiment 1, n1 ways, experiment 2, n2 ways, experiment 3, n3 ways, all the way up to experiment k, n sub k ways. Product of all of them, so the total number of ways would simply be n1 times n2 times n3 times ... nk. Good. And you may say, this doesn't make sense. Let's do something simple. Yes.
Multiplication and 1 times n2.
Yes. Well, perhaps we should do this. Have you guys seen this before?
No, I was maybe, but I forgot it's cool.
Capital pi or huge pi, j equals 1 to k, just like summation, this means product.
Oh. I guess I'll have to vote.
Is that notation going to be on the test?
Huh?
Is that notation going to be on the exam?
Could be.
Okay. So we should know it.
You should know it. It's similar to a sum. Yes.
Why do you have k equals all the way up to n?
Should we use a different
No,
level?
but I'm saying because if you're listing it as n sub k and it goes k equals 1, 2 all the way to n, then what the last one be n sub n. You get what I'm saying?
I don't want to confuse yourself, but ends of capital. Yes, I got it. So let's say we toss a coin. Between 1 and, no, not 1, between 2 and 8. Give me a number. 3. Toss a coin twice. simultaneously. Now, we know that they're all going to be independent, right? The first coin, just because it produces a head, doesn't imply that the next one would definitely give you a tail and so forth. That's it. We want to know in how many ways they can all happen together. How many ways in the sense, how many possible outcomes do we have? Well, for coin one, number of ways or outcomes, how many do we have? 2. So in our case, that is N1. Coin 2, number of ways in which it could happen? 2. N2. Coin 3, number of ways in which that could happen? N3. Yes, so capital N in this case will simply be 3. So we have 3 experiments. In total, in how many ways could it happen simultaneously? So coin 1, coin 2, coin 3. It's always good if you guys, follow the sort of trick, you can either put lines for each experiment or put parentheses or brackets for each experiment so that, it's easy to follow. So coin 1, 2 ways. Coin 2, 2 ways. Coin 3, 2 ways. In total, we have 8. Can I erase this part? Okay. Here is the question. Why did you tell me that there would be 2? Heads or tails, right? So if I look at the sample space, heads or tails, same here, and same there. If I want to write them all out, do you think that we would get a possibility? We better, right? So, easier way to do this. Some like to draw a tree or tree diagram. Some like to do this. Entirely up to you, as long as you get it right. The first I'm going to consider 2 points, right? So the possible outcomes are HH, HT, TH, and TT. Yes?
Are you considering HT and TH to be different outcomes in this?
Yes. You read my mind, I was about to mention. So coin 1, coin 2. So I'm treating them as separate entities. And they are separate experiments. There is no, we can't interchange them. The next step is the third coin. So we know that there are 4 possibilities for the first 2 coins. The third one will depend on the previous outcomes. And what are the possibilities for the third coin?
H and T.
H and T. So you would have HHH, HHT, HTH, HTT, THH, THT, TTH, and TTT. That's not TQ. If it's a probability, then it is a Q, right? So, including the third one, including so how many do we have? 8 possibilities. This is not great, you know. But do you really want to sit around and write things out? Imagine this is fine. What if you had 50 of them? We're going to be here for a long time, you know, we can live. So our objective is to simply find the number of ways something would happen. That's why we looked at probability from a sense of cardinality. When we find the probability of an event, all we are doing is finding the number of ways in which the event would happen divided by the total number of ways. So if I can find the number of ways, I don't care about writing them out. Correct? Because all I need is the number of ways. I don't want, you know, those. So we need to have some sort of methodology or rules, and those are counting